All right, well, today we get into examining the effects of outliers. So we're going to use a couple baseball examples here to do that. All right. So focus today is what is an outlier and how does it affect the average for a set of data? So in our first table, it's home runs by Detroit Tigers baseball players. And this shows the number of home runs hit by the Detroit Tigers baseball players during the 2013 season. So there you can see a list of numbers. And as you can see here, a lot of that, there's a couple low numbers here, a 6, 9, and a 7. Most of the numbers are in the teens. And then kind of Miguel Cabrera is out on his own. So it says, which player appears to be an outlier in the data? Well, that would be Miguel Cabrera. Because, again, you can kind of see that his number is kind of way outside. You see a lot of the numbers here in the teens, and then kind of a few that are a little on the lower side, but most of them are in the teens, and he's way, way out there at 44. So how do you know? Well, his home run number is significantly higher than the rest. And it says, sketch a quick histogram of the data. So if we, from 0 to 9, we have 3. So that means here, and then from 10 to 19, we have 1, 2, 3, 4, 5, 6. And then we don't have anything from 20 to 29 or 30 to 39. We have 1 from 40 to 49, which is there. All right, and there's our histogram. All right, so really quick, because I kind of did this already, I'm just going to write these numbers in order. And this totals out to 141. Okay, so we will need that in just a second. So let me, I'm going to lock this so it doesn't erase. There we go. Now if I go to erase it, yeah, it won't let me do it. So I can scribble all over it and it won't erase. That's what we want. All right, so for the mean, it says find the mean, median, and mode for the number of home runs, but do not include the outlier. All right, so we're going to take away this number. All right, and by doing that, we got to take away 44 from 141, which is 97. And there's 9 pieces of data. So when I take 97 divided by 9, I get 10.8. All right, my median. So if I count, there's my outsides. We're going to cross those out. We're going to work our outside in, here to here, here to here. So there's 4 on each side, leaving me the middle. So there's the median, which is 11. And the mode is the number that appears the most, which is also 11. Okay. Now, we go to the data that includes the outlier. So that's 141, because we told that already for you. And we're going to divide that by 10. which makes 14.1. Now if I do the median, we go here and here, and then working our way into the middle. We got 2 left. So again, if we average these together, we got 11 and 11. Well, if you kind of do it technically, this is 22 over 2, which is 11. You knew that was 11 already. And then the mode is still 11. So the mode and the median don't change for both sets of data. The mean changes. So it says when Cabrera's number of home runs, the outlier, is included in the calculations, which measure of central tendency is the most accurately represents the number of home runs of a typical Detroit Tigers player and why? Well, that would be the median. And that's because his number is so high, it skews the data. Meaning it makes the mean higher. All right, so based on the sample data, make a conjecture about the mean, median, and mode for the entire Detroit Tigers home runs. Justify your conjecture. Well, due to the outlier, the mean is skewed up because that made it higher, right? It went from 10.8 to 14.1. The median and mode are the same. Remember, they never changed from 11. Making them the more accurate measure of central tendency. Now down below, it says the definition of an outlier is a point which falls more than 1.5 times the interquartile range above the third quartile or below the first quartile. So prove that Miguel Cabrera's home runs is a true outlier according to the definition. Well, again, if I put the data down here again, all right, and I know the median was right here, right, which splits this data into 2 sets. So here is the quartile 1, and here is quartile 3, right? So if I know that quartile 1 is 9, and quartile 3 is 14, because our median was 11, 14 minus 9 is 5. And that 5 is our interquartile range. Okay? Now, if I take that 5 and multiply it by 1.5, because again, it says a true outlier is 1.5 times more than the interquartile range above, this would be quartile 3 because this is in the higher end, right? Well, that's 7.5. So if I take the quartile 3, which is the higher end at 14, and add 7.5 to it, I get 21.5. Well, so anything higher than 21.5 is considered a true outlier. While Miguel Cabrera's number was 44, which is way higher than 21.5. So that would be considered a true outlier. All right, let's move on to our next scenario. Page 3. So data set 2 is the games played by the Detroit Tigers baseball players in 2013. And you can see here we got a lot of data, a lot of numbers in the hundreds, and then Doug Fister is at 33. So it says prove that Doug Fister's games, 33 games, is a true outlier. Well, again, if we put this in order, all right, and let me just do some text stuff here so I can lock this up so it doesn't, oop, I didn't want to do that. Let's try that again. All right, so now that's not going to do anything. So now, we know the median of this. Well, I did some other things too. I added, so if I add this whole number of games played, it's 1,233. So we try to do some things to help save some time. So if I get rid of the, going outside in here, so that means the median has to be between these two numbers, right? Which is going to be right here. And if I add those two together and divide by 2, so we know that basically this set of data is one and this set is another one, which makes this the quartile 3, and this is the quartile 1. So our quartile 1 is 107. Our quartile 3 is 148. So if I want to figure out the interquartile range, I'm going to subtract 148 minus 107 to get 41. That is our interquartile range. And remember, it has to be 1.5 times. So 41 times 1.5 is 61.5. Now, Doug Fister's number is on the low side. So we have to take quartile 1, which is 107, and subtract 61.5 from it. And when I do so, I get 45.5. So any number below 45.5 would be a true outlier. And since Doug Fister's number is 33, his number would be a true outlier because it lies way outside the data. Okay? So if we scroll down here, and we figure out the mean, well, that 1,233 was the total. So if we are not including the outlier, if we subtract 33 out of the 1,233, that's just 1,200. And that's 9 pieces of data, which would be 133.3. It repeats, but we'll just round it. The median, which we kind of already figured out, right? It was 129 plus 131 divided by 2, and that's 260, which is 130. So that was the median. I'm sorry, not 130. Yes, I'm sorry, 130. Oh no, I'm sorry, I screwed that up. Let's go back up to here. We got to take out the outlier, right? So when I make my new set of data, where am I going to write that? I'm going to write it below here just so you can see. So 102, no 33, 107, 118, 129, 131, 144, 148, 159, and 162. Well, if you notice here, there are 9 pieces of data, right? So 4 are to the left, 4 are to the right, which leaves this one right here in the middle. There's our median. And then our mode is the number that appears the most. Well, there's no number that appears more than once, right? So there is no mode. Okay? Now, if we include the outlier, which is in number 3 on the table to the right, Now we have 1,233 in 10 pieces of data, which is 123.3. The median is now the middle. Remember, it was 129 plus 131 divided by 2, which is 260 divided by 2, which is 130. Okay? And again, there's still no mode. There's nothing that appears twice. All right? So if we go ahead and it says calculate the outlier affected, calculate how the outlier affected your mean and median. So the difference between the means, the mean with the outlier, well, the mean with the outlier was 123.3, and the mean without it was 133.3. So if we subtract that, we get negative 10, which means there's a 10-game difference, okay, between the means. Where if we do the median with the outlier was 130, and without it was 131. So that's only a difference of 1. All right. So it says, did the outlier have a significant effect on the value of the mean? If so, what was the effect? Yeah, it had a significant effect. It was a difference of 10 games. Did the outlier have a significant effect on the median? No, because the difference was only 1 game. So it was a little bit much tighter. Okay, 10 games is quite a bit more than 1. All right. If this data set had a mode, would the mode be affected by the outlier? Okay, and that is no, and because the mode is the number that happens the most. That's the number sign, by the way. Number that happens the most. Okay. So the outlier would have nothing to do with it. Because the median is still in the middle. The outlier would affect the mean, not the median. So when you add the mode, that's just the number that appears the most. It's still going to be the middle data. It's not going to affect the mode at all because it only is the number that appears twice. So it says, which measure of central tendency most accurately represents the number of games played by a typical Detroit Tigers player and why? Well, that would be the median. And because the outlier skews, it's a bad E, the data on the low side. Remember, it lowered at 10 games, right? When we put the outlier in, it took the mean from 133 games down to 123. It only took the median down from 131 to 130. So again, with the least significant loss, the median is the more accurate measure of central tendency because there's just too much distance between the two means. All right, let's go to our summary. So the summary here, it says, how are the mean and median related in a data distribution that is skewed left? So remember here, it's skewed left, which means all the data here is to the right, and you see kind of the outlying information here. So the mean is less than the median because the median is going to kind of occur in this area where the mean is going to kind of occur over here. So again, that's why we say skewed left. It's going to pull all this data this way a little bit. All right. Now what happens when it's skewed right? That would mean the mean is greater than the median. Because again, the median is going to be somewhere in here. The mean is going to be somewhere out there. So it's going to pull that to the right, which is why we say skewed to the right. If a data distribution contains an outlier, is it better to use the mean or the median to describe a typical value in the set? Do we want to use the median? Because the outlier influences the mean. And it would influence it by either, depending on where it is, making it higher or lower. But it doesn't affect the median. Because again, that's just the middle number. And then if a data distribution does not contain an outlier, is it better to use the mean or the median to describe the typical value? Well, actually, in this case, both are good because there's no C there. Both numbers will be close to one another, meaning they're not going to be a great loss there because of that outlier. However, the mean is more generally accepted the more generally accepted measure of central tendency. That's kind of the preferred if they're both the same. And would account for a significant number of larger or smaller data. Okay. So both would work, but again, mean is usually the general perfected. Now it says, how are outliers shown in a box plot? So I'm going to actually draw one for you. All right, so here's my box. Okay. So there's my median. There's my quartile 1. Here's my quartile 3. All right, here's my whisker with my minimum. And there's my other whisker to the right with my maximum. So what would happen would be an outlier would be something out here. Outside the minimum or maximum. These would be what the outliers would look like. They would be an asterisk outside the set of data. Okay. So what you're going to do now with the checking for understanding, and we'll check this on Monday. Okay. You're going to create a box plot for which the number 20 is an outlier. So that's got to be outside the data. Okay. High or low doesn't matter, but that's your outlier number. Label the 5-number summary underneath the appropriate points on the plot, and then you're going to draw a dashed line where the approximate value of the mean would be. Okay, so I want you to work on this for Monday. We will go over it on Monday and see how you did. All right, so we hope this helped, and that is the notes for today.